Welcome to the Scientific Sense podcast, where we explore emerging ideas from science, policy, economics, and technology. My name is Gil Eapen. We talk with world's leading academics and experts about their recent research or general areas of topical interest. Scientific Sense is an unstructured conversation with no agenda or preparation. We cover a wide variety of domains where new discoveries are made and new technologies are developed on a daily basis. We are most interested in how new ideas affect society and help educate the world how to pursue a rewarding and enjoyable life rooted in science, logic, and information. We seek knowledge without boundaries or constraints and provide unedited content of conversations with researchers and leaders who love what they do. A companion blog to this podcast can be found at scientificsense.com, and this podcast is available on over a dozen platforms and directly at scientificsense.net. If you have suggestions for topics, guests, and other ideas, please send them to info@scientificsense.com, and I can be reached at gil@eapen.info. My guest today is Professor Douglas Duncan, who is emeritus faculty member in the Department of Astrophysical and Planetary Sciences of the University of Colorado and former director of the Fiske Planetarium. Is it Fisk or Fiske, Doug?
It's Fisk.
Fisk Planetarium. Sorry about that. And before that, he was a Carnegie Fellow on the staff of the Hubble Space Telescope and held a joint appointment between the Alder Planetarium and the University of Chicago. Welcome, Doug.
Thank you, Gil.
So your background, obviously, a lot in astronomy and physics, but your passion now, Doug, if I understand this correctly, is teaching a couple of classes. One of them is, I don't know the exact title, but Nature of Science using Pseudoscience. Is that right?
That's right.
And other classes. So pseudoscience has become a big problem. We have seen this in politics, in large democracies, as social media dominates conversation. This has become a real problem, as most people recognize now. And generally, I don't know the exact statistics, Doug, you may know this. I recently realized 25% of the public in the US believe that the sun goes around the earth, and something like 50% of the population do not believe in evolution. And so we have a very large population who don't actually believe in what we consider to be sort of at least basic understanding in sciences. And so you're focusing on teaching students, but I want to start with sort of this general problem for the public. So what's your perspective there? What can we do?
Well, the most important thing in my perspective is to place the blame solely on professors like myself, universities like the university that I'm part of, schools.
Yeah.
They are not teaching a very essential skill. And that's the skill of how to navigate in the modern world, which is a scientific and technical world. So what I always tell my students, and I specialize in teaching classes to people who are not science majors. And even when I teach about good versus bad science or real versus fake science, it's usually as a part of a really fun astronomy class.
Yeah.
And I try and make this truth versus untruth telling to be as much fun as possible. But as you suggested, it's actually very, very important also. You know, it wasn't too long ago that we lived in a world filled with very scary, unscientific things.
Right.
It used to be if you were sick, they would take a chisel and a hammer and they would chisel a hole in your skull. That was called trepanation. Okay, and that went on for many, many, many years. And perhaps you could understand why we would do something like that, because the people who recovered said to the person who chiseled a hole in their skull, "Thank you for saving me." And the people who died, they never complained.
Right. So it's a biased sample. Yeah.
That's what's called a biased sample. But the very idea of what is a good sample, what is a biased sample, what is a story versus what is a scientific experiment, that's something that had to be developed. And it only developed a couple of centuries ago. But it's so important. It seems to me very, very important that the ordinary student, the ordinary citizen, understands enough about how science works to use it beneficially for themselves.
Yeah. Let me make a statement, Doug, and I want to get your views on this. So I was having this conversation actually yesterday with somebody, and I stated that science could be considered religion. Religion was sort of the original science, and now we have the current science, but it has some characteristics that are similar to religion, in the sense that, there are a lot of biases in it. There is confirmation and confirmation biases. As you say, universities' objective function may not be very clean. Even professors who are looking for tenures and publications tend to conform.
Well, I have to jump in here, Gil, because I didn't say that, and it's also contrary to what I have observed.
Okay.
In my 40 years at a number of different universities.
Yeah.
I think the scientists themselves, overwhelmingly at universities, are in pursuit of a real understanding of how the world works.
Yeah.
And, do they like their ideas to be proven wrong? Of course not. Nobody likes to be proven wrong. But in science, you basically pledge to accept what the data shows and what other scientists have discovered.
Yeah.
And even though it's true that all humans have, biases of one form or another, the very method of science is extremely effective at counteracting bias. And what I mean by that is, as soon as a scientist publishes something, other scientists look to see if it's true. And so they try and repeat the experiment.
Yeah.
And if the experiment, just works in Utah or something like that, and it doesn't work in India, and it doesn't work in Brazil, then the bulk of scientists are going to reject it. So, the results need to be verified.
Right. Yeah. So that is true. So, but we do have, Doug, an issue with replication. Many of the studies, for example, I've been, closer to life sciences more recently. Some of the studies, not some, a large percentage cannot be really replicated very easily. And
And the reason, of course, the reason you know that is that a bunch of people tried to replicate them, and they couldn't.
That's right. So that's what you're saying, I think, Doug, is there's a self-policing aspect to it, right? That makes it work better than just.
It is. I think it would be interesting to know, like I said, scientists do have their biases. And for instance, if you think you've discovered something that you think will either make you famous or will make you a lot of money, there's a very strong temptation to rush that into print as soon as you can.
Right.
And that's why I think the idea that papers get refereed and if you're going to publish in a scientific journal, you have to have your paper examined by 2 or 3 other scientists. And they certainly don't catch all the mistakes, but they catch some.
Right.
One of the things that worries me a little bit is because people like wealth or fame, there is a temptation to shortcut that process And maybe you publish just by putting something online, which you can do, without being carefully refereed. Or even worse, just have a press conference. And I think you see that play out. You see it especially with COVID, for instance,
Right.
that the companies that are working so hard to make vaccines, and if they succeed, they'll make billions of dollars, but they'll also save lots and lots of lives.
Yeah.
You notice that some of them have held press conferences before they've even published their results.
Right.
Now,
Yeah.
I don't think that should be banned, but I do respect the many scientists who have said, well, this is really exciting, but it's only a press conference. But
Right.
we want to see the actual data before we would take the vaccine ourselves or recommend it to you, the listener, to take the vaccine. So I actually think that's a pretty good illustration of how science is supposed to work.
Yeah.
We all want really fast results, and I would criticize the scientists who move too fast, and hold their press conference too early. But I also think that the average citizen needs to know.
Right.
The average citizen wants a tweet. They may not even wait for your podcast, because heaven forbid, they might have to wait a week for you to put it together and put it online, or a few days. And so one of the things that I teach students in my real versus fake class is simply to ask them to ponder whether information is more likely to be valuable if somebody gave it to you within minutes of hearing about it, or is it more likely to be valuable and accurate if the person thought about it for a day, researched it for a few days, and then gave it to you?
Yeah, I fully agree with that. So I think what you're saying is that really it's about the process. And so the way that I will think about it is that, my mom does this all the time. She just needs to read it somewhere or listen, to the radio or something, and somebody said something, and that is taken as sort of ground truth to make set of conclusions. So I would say, at the very least, in a simplistic way, I would think that when you hear something, you have to ask why, how, some basic questions.
Oh, absolutely.
Yeah.
And I will circle this back and say that our education system is dramatically failing the average person by not giving them the tools to do what you just said. When I was in school, they taught you reading, they taught you writing and communication skills, and they taught you how to find information. And what they taught you was, you go to a library, this is where all the books and magazines and records are, this is how you look up a subject, and this is how you find information. Now, that was not as convenient as today. You had to go in person to the library. But it did have a very important safeguard, and that is that for a book to get into the library, somebody put it there.
Right.
Usually the librarian, and I've known a lot of librarians in my day, and I love librarians. And they are all very, very conscientious at putting worthwhile books and magazines in libraries. Well, okay, most people don't go to libraries now. You just turn on your phone, and information comes pouring out. The problem is, a pretty high percentage of that information is garbage.
Right.
It's wrong, or even worse than wrong, it's designed to fool you. And schools are way, way behind times in not teaching every student how to handle information in the 21st century rather than the 20th century.
Yeah, that's really interesting. So 40 years ago, the search and acquisition cost of information were high for an individual, for a student, for an individual more generally. Because you had to go to the library, you have to seek information out, you have to sit down, you have to read, you have to internalize. It's high cost activity.
That's
and
right.
now it's zero cost activity. I mean, to get the information, to get data, it's nearly zero cost activity. And so behaviors that were, put into students during their education time in terms of how to get, analyze, and internalize data, was already considering that search and acquisition costs as part of that equation. And now world has turned upside down, right? That those costs have gone to zero.
And it's very interesting you put it that way, Gil, because I'm gonna relate this to something that all museum directors know.
Yeah.
If you put on a program at a museum, you can charge for the program. Or in some circumstances, you can give people money for attending a program. Let's say you want their opinion about something. We'll give you all a ticket to some program at the museum. But the one thing you should never do is to make an event zero cost. Because if you make it zero cost, people do not treat it as seriously as if either they are paying you or you are paying them. And so
Right.
I just wonder if when we're flooded by lots of information which is at zero cost, it just shows up. Maybe we're not treating that seriously enough.
Yeah, we're definitely not treating it seriously, but I think, if I understand you correctly, Doug, it's also a situation that you take that information as valid, right? And so in the library, as you said, there was a gatekeeper. There was sort of a process to assure that garbage doesn't get in. But there is no process on Facebook or Google or internet in general that curates information.
Exactly right.
Right? Yeah.
Nobody is going to do this for you. And therefore, the prime responsibility falls onto each and every user.
Yeah.
And it's almost a survival skill nowadays.
Right.
I mean, it's one thing to think that I don't know, that the government is poisoning you all because when you look up in the sky you see contrails, which in fact have been up there ever since I was a little teeny kid, but nobody ever pointed it out and said, look, oh my God, they're poisoning us. Well, that's kind of funny.
Yeah.
And I don't know anybody that's died from it. But when somebody posts coronavirus is just a hoax, don't worry about it, go out and socialize with your friends, that becomes a real matter of life and death. For 30 years, I have taught students, I've said, even if you're not a scientist, science is going to have a huge impact on your life. And so you need to discover how to tell for yourself what's believable science and what is exaggerated or worse, trying to fool you. And I never thought it would be so dramatically revealed, the importance of that. But right at this instant that we're recording, we are living through a time where choices based on science will cause tens of thousands of people to live or to die. So I don't think I was exaggerating when I was saying an essential skill to live in the modern world, is to be able to judge for yourself what's valid and what's fake.
Yeah. So I want to talk about the students first, and then sort of go to the general public. So I wondered, Doug, I grew up in India, just like many Asian education systems. There is a lot of rote learning. I tend to think that it's less in the US, but you probably can tell me how. And I'm thinking about sort of early schooling, high school, early college, those types of things. And
Yeah, that's an important and complex question.
Yeah.
There are certainly parts of school and schools in the U.S. that have very good education. They're more engaging of the students. They actually cause the students to think rather than just memorize and regurgitate.
Yeah.
I think that the probable overemphasis on standardized testing tends to work against that some, because it forces some teachers to only teach what's on a test. So I think there's good and bad going on. But I think there's something a little more subtle going on also, and it particularly affects people who teach science.
Yeah.
You see, when I learn a scientific principle, let's say I learn some law that Isaac Newton first found out about forces and motions. Once I've learned that principle, I'm always on the lookout for where it applies. Oh, that determines whether a bridge is going to stand up properly or a tall building.
Right. Yeah.
And so that's in education, that's called transfer of knowledge. You learn something in one context, but you apply it in many different contexts. And scientists are trained to do that, and we do it all the time. The mistake we make when teaching is to think that if we just show one example to the students, then they will automatically transfer it to everything they do. So if we show them how Galileo was the first person to say, you got to experiment and test your ideas, most classes will stop after they taught a little bit about science and Galileo. And the teacher will assume, okay, now my students know the scientific method. When they hear something on the internet or see something on TV or hear something from a friend, they're going to automatically say, oh, I wonder what the experimental evidence is behind that. And of course, that's false. People don't automatically transfer. And so if you're teaching science and you want students to use it in their everyday life, there really is no substitute for giving them some homework which is in their everyday life. So that's why I had a lot of fun teaching science by good versus bad, or real science versus pseudoscience, because every other week I send my students to the internet, to websites, to YouTube videos, and always one of them is legit, and one of them is bogus. It's fake. It's trying to fool you or take your money. And then the students have to tell each other which things that they've heard on social media or they find on the internet they believe. And the more they talk about it, the more they start to understand what different people's criteria is for distinguishing truth from fiction. But they do it in the context that matters, which is in their own real world. And it's kind of interesting. A big percentage of my students, maybe 3/4, have told me at the end of class, this is the most valuable thing I ever learned in a science class. I'm not a scientist, but I know people who've been sick and they have to choose medicine, or I'm concerned about climate change and I want to know if it's real, and now I know how to find out the good information. And maybe 15% of my students say, oh, I hated that. All that stuff you gave us to do on social media and YouTube, it's not in the astronomy book. I can't even find an answer key on any of those websites that I go to help me with my homework. And so, I hate it. I kind of think that 15% will benefit as much or more as the other students. But it is not typical in science classes to teach people how to use the internet and how not to get fooled.
Which has become increasingly more important. So if I abstract this, Doug, let me know what you think about this. So, if I think about education, so there is raw data, there is a process of converting that data into finished goods, finished products. It seems to me that the current education system or the education system last 60, 70 years has put a lot of importance on both ends of that process, that whole continuum, right? For instance, the physics books that I used is the same physics books, different version, but the same physics books that my daughter used 25 years later, 24 years later. Even the examples are the same. So you say, here is your data and this is the answer. So you go figure out how to, how do you get the answer? The answer is quite important, right? Both the data and the answer is quite important. But the process of getting to the answer, I think we have provided, I think, less and less importance to that. And part of that, I wonder, is just the examination, as you said, the standardized tests and so on. that actually require people to focus on the answers?
I couldn't agree with you more, Gil. I think that's tremendously important. And by the time students get to me freshman year in college, they are so directed toward the answer. What is the answer? What is the answer? That's all they care about. And I think the standardized tests are a little bit to blame. I think that teaching, I have seen examples of teaching that's very good, that does emphasize the process, that lets the students go through the process. There's two reasons why that isn't done more, I think, that I've observed. Number one, it's a little bit messy. Okay, in real science, you try something, didn't work. Okay, I got to try another approach.
Right.
Oh, damn, that didn't work. Okay, the third approach worked. Well, that's how science actually works, and you learn so much from your failures and from the process as well as the answer that you find, but it takes more time. And so if you have been told as a teacher, here's the physics book, it's got 28 chapters, you have 14 weeks, cover 2 chapters a week. The system is not giving you time to actually learn how to do science or even how science works. So the fact that it takes more time and is a little bit messy is a disincentive. And then secondly, if all that matters is the answer, then the teacher can keep a list of answers, and they can use it this year, and they can use it next year, they can use it next year, and nothing ever goes haywire. Whereas if you give the students more freedom and what they do is more open-ended, they may very well end up in a place that you didn't expect them to end up. Now, I quickly want to add, nothing is more valuable. Nothing will stays with students longer is when they suddenly make an unexpected discovery. And it happens a lot, but it only happens if the instruction is tailored to let that happen. So I am agreeing with you 100% that we have a way overemphasis on answers. And the problem with that is that answers change. Science, the best description of science, one of the very best that I know of, is that science is like a crossword puzzle. If you're a scientist, you work really, really hard, sometimes for years, and you discover something and you get to write in the word, and it's very satisfying. But it has to agree with the words of all the previous scientists, what they've discovered. And so little by little, you start to fill in the crossword puzzle of science. And then, every once in a while, something amazing happens. You find a word, and it doesn't fit. And so you check your word, and you check your work, and yes, you're sure that what you found is right, and so that means that somebody before you made a mistake. So you get out the eraser, and you erase that previous word, and you tell everybody, we've discovered they made a mistake, and you put in. And so little by little, science, like a scaffold, builds on what happens in the past. And if people understood that, they would understand and be, I think, much more forgiving and understandable that, for example, for a few weeks, scientists were saying you don't really need to wear a mask. We think you should prevent COVID infections by cleaning all the surfaces. Well, then as more experimentation was done and more observations, they started to realize that COVID could be transmitted through the air. And they changed their recommendation. It's not because the scientists were lying to you for 2 weeks and then suddenly are telling you the truth. It's that little by little they've been learning more and more and more about this virus. And if people had been taught science in the proper way, to see how it works, that wouldn't surprise them. But since 95% have been only taught answers, I got to just continue as an astronomer. A perfect example of this is how many planets are there? Okay?
8
I don't know what your listeners are going to think, but you're hearing from one of the people who voted Pluto off the island. Okay? I was one of the astronomers who voted for there to be 8 planets. Now, why did I do that? When I was a kid, there were 9. But over the last 20 years or so, we have come to realize that out by Pluto, it has hundreds of friends that are very, very similar to Pluto and not very similar to the 8 larger planets. So we've advanced in our understanding. We found there's a new kind of planet or a new kind of object, whatever you want to call it, exemplified by Pluto. So the answer changed. It went from 9 planets to 8 planets, but the method didn't change.
It might come back, Doug, because there is apparently a planet 9 out there.
Well, we don't know for sure. Okay, but the way they found Pluto is there seemed to be something tugging on Neptune.
Yeah.
And now there seems to be something tugging on the outer planet still, but it's very subtle. And so I think I have not seen enough evidence yet to be convinced whether an extra big planet is out there further out or not yet. I'm fascinated by the search. Right. You know, indirectly, Gail, you've brought up something very important. One of the most fascinating things I've learned in my whole career in science. Very early on, I was taught that as a good scientist, if you don't have enough evidence to come to a firm conclusion, you say, we don't really know. I don't really know.
Right.
And what I've learned over all my years in science is people hate that. People hate uncertainty. I wish I had $1 for every time I've been badgered by somebody who's not a scientist. But what's the answer? Is there another planet? You gotta know. You're a scientist. And that's a misconception about how science works. And unfortunately, and I'm not a psychologist, you should talk to one, I think that people do feel very uncomfortable when something is not settled. And in that circumstance, they are very likely to accept a conspiracy theory that explains everything, right, rather than having to say, we don't know.
Yeah, we will take a quick break, Doug. I want to explore this idea. I think it's a very interesting way to think about it.
Okay.
That people don't like uncertainty. And so anything that sort of stand in for reduction in uncertainty is given higher level of validation some way.
Yes.
So this may have implications. So I want to talk a bit about the general public as well when we come back.
Sure. Okay. I'll look for your link, and then we'll do a new link.
Sounds good. This is a Scientific Sense podcast providing unscripted conversations with leading academics and researchers on a variety of topics. If you'd like to sponsor this podcast, please reach out to info@scientificsense.com. So we are back. So Doug, we are talking about scientific education. You have a college course entitled 21st Century Literacy for Succeeding in College and Beyond. One of the issues, so we can see this as a symptom in the general public who seem to get information from social media and other avenues. There is an information overload. And one of the things that you were talking about in the last session, which I haven't really thought about it this way, is that people don't like uncertainty. And I see that in finance and economics, for example. There is sort of an Excel generation out there. They like numbers, deterministic, precise numbers put into Excel spreadsheets. And once you say, well, that number has a lot of uncertainty around that, a lot of people are not very comfortable with it. And so in some sense, when you're sitting in front of, your Facebook page or some other social media, you're actually craving for some sort of, conclusion, or somebody saying X is precisely that. And anybody saying, we don't really know, it could be uncertain, is somewhat uncomfortable.
Oh, it's more than somewhat. It's very uncomfortable. And
Yeah.
perhaps all of this focus in schooling on the answer, makes it even worse, right? The students actually believe that there's always an answer.
Mm.
Uh, you know, I actually have pretty fun example of that. I'm kind of famous around the University of Colorado. There's a big tower on campus, about 10 stories tall,
Yeah.
called Gamov Tower, named after a famous physicist. And I have my non-major students measure the height of Gamov Tower.
Mm.
And I give them big cardboard triangles where one's about 2 feet high.
Mm.
And one side of the triangle is 2 feet long and one side is 1 foot long. And I tell them that it's in a shape where the sides are 2 to 1. And I give them a meter stick and I ask them to go outside and measure the height of the building. And they are stunned. They are frozen in place. And of course, all of them say to me, how do we do this? And I say, well, you use your imagination and your creativity. I think with these tools, you can come up with a way of measuring the height of the building without climbing it.
Yeah.
And eventually, one group of students figures out a way and starts to measure the height of the building. And when all the other students see them citing and doing something, they quit complaining. And then pretty soon, I have like 50 different measurements of the height of the building. And I plot them all on a histogram.
Yeah.
And we talk about why didn't everyone measure the same height of the building? Well, the answer is there's always some uncertainty in measurements. And I ask them if they think there's uncertainty in scientific measurements. And they go, oh, you mean even professional scientists? And I go, yeah, it's called experimental error. And it's always there, okay? And so then what's also interesting is always out of 50 students, a handful will make a mistake. And so a couple of data points are totally different than the rest. And we talk about why it's important to have more than one experiment so that you know if somebody made a mistake and there's some data you got to throw out. Okay, when we're done with all that, they say, okay, now tell us really the height of the building. Well, it turns out that the blueprints of the building were actually accidentally destroyed. And so there is no answer from God, so to speak, what is the height of the building.
Right.
The best answer is their measurements. And they are so disappointed at this that there isn't an answer in the back of the book. And I think this is so important because we live in the real world. When I and other astronomers go out to measure how old are the oldest stars or how long has the universe been expanding, and we know that our universe began a little over 13 to 14 billion years ago, there's no book where we check our answer. You know, we just make our best measurements and we say, this is what we think, and this is the uncertainty in it. And those are such important concepts. And most people have not been taught that no answer is perfect. Every measurement has some uncertainty, and you should get the best information you can and be honest about what the uncertainties are. And people are so hung up, tell me the real answer, that it really fights against the way the world actually works. And if someone comes along and just says, hey, believe me, I've got all the answers, it's astonishing how many people will follow people like that, apparently because they want an answer. And unfortunately, that is the road. That is right down the center of the road to being fooled, to making yourself be gullible, to making yourself be a mark and a target. It's very sad.
Yeah. I mean, I can see why people would do that, Doug. So, the cognitive cost of internalizing an information is actually a lot lower when there is a lot of uncertainty, right? So if you have some information that has a lot of uncertainty in it, that requires you to spend more time. Your brain has to be occupying that information a lot longer, right? So the cognitive cost is higher, and so naturally, I think people will will kind of move away from that and seek a situation that is of lower cost, which is somebody saying X is equal to Y.
So, right. I agree with you, but I would focus on the word naturally. You have correctly described what people naturally do. However, the purpose of education is to go beyond just the intuitive things that we would naturally do.
Yeah.
And to teach us things which are valuable and are not things that anybody would just do on their own.
Right.
Okay. So, it's the most natural thing, as far as I've observed, to judge by appearances. Oh, that person doesn't look like me. They must be different from me. When I turned 21, I served on a jury in a criminal case, and as it would happen, I was voted jury foreman. And I was just a 21-year-old, and it was a criminal case, and there were 12 people on the jury, and we heard all the testimony, and it was absolutely clear to me that the defendant was guilty. And we went back in the jury room, and I said, okay, we're going to talk about this, but let's just see where we start from. So we had a secret ballot, and 10 of the jurors voted guilty, and 2 of the jurors voted not guilty. And I said, well, if you're comfortable before we begin our deliberations, would either of the 2 people who voted not guilty explain why? And one lady immediately popped up, and she said, he's such a nice-looking young man. He's very clean cut. I just don't believe that he could have committed a crime. And I think that what she said is kind of natural, to just judge on the basis of appearance. But let's say that you're a judge. You're trained to think about evidence. Or let's say that you're a military leader. My understanding is, although I've not been in the military, that they spend a lot of time in officer school helping people take a lot of different inputs and think carefully before they have a military response. And not just strike back because you've seen somebody strike you. So I think that an important part of education is to equip people with understanding what their natural response is, but to help them realize that doesn't have to be your only response. There's a wonderful book, by the way, I think we should recommend to all of our listeners. It's by a Nobel Prize winner, and you may have encountered this book. It's called Thinking Fast and Slow.
Yeah.
And Daniel Kahneman, who wrote it, I think it comes out of economics, is where his Nobel Prize is. It's not psychology, but it's basically a psychology book. And he says that we have 2 kinds of responses, the ones we instinctively have right away, but also the ones we take more time to think about. And I agree with him that it's really important to equip people to realize when it's their instinctive rapid response that's jumping in, and to equip them with the ability to make the more thoughtful decision as well, before they get fooled, before they cause a problem.
Right. And so I can see that from an education perspective, Doug. I want to ask you, given the situation that we are in, and I'm talking specifically about the U.S., 330 million people, we have data coming to us in very large quantities, most of them likely incorrect, but people are willing to buy it, believe in it, act on it, which makes the democracy, the democratic system that we have is probably teetering on the edge, with that sort of a condition. So what are the solutions that we could try? I mean, education, redesigning education as you described is definitely worthwhile. But given that we have these initial conditions in the public, what do you think we could do?
Well, I think that's a very important question. I'm going to be very much the scientist, okay? And the first thing I'm going to tell you is I certainly don't definitively know.
Yeah.
Secondly, I do think that this is a deep-seated problem, and therefore one should expect to have to do a lot of incremental things over a period of years in order to fix the problem. It's just kind of like if you're overweight, for instance, and this is a complicated example because there's a lot of physiological things that affect weight. But one thing we know doesn't work is to go on a crash diet for a month and then think you're going to be fixed. No, it's much more effective to do little things constantly over time.
Right.
And I think we're going to have to do the same when it comes to misinformation in our society. One of the things I think we could do rather quickly is it's just a historical happenstance that if I publish a newspaper and I publish something which is false and harm you, I'm responsible for that. You can sue me, but you cannot sue Mark Zuckerberg. You cannot sue Facebook. You cannot sue Twitter because of laws that we passed a couple of decades ago saying that the social media companies are not responsible for the things that appear on their pages.
Right.
Well, that didn't come down from Moses. It's something we did, and I think we should think seriously about undoing. Okay? If you post something, we know you can't cry fire in a crowded theater because people will be trampled and die. And you can't put up posters or you can't publish a newspaper that specifically tells harmful lies about someone. You can be sued. So I rather think that we need to undo the blanket lack of responsibility that we have legislated for social media. Now, I'm well aware that as soon as you do that, in order to be responsible for what appears on Facebook, they're going to have to hire not just 100 people, but 10,000 people to vet the stuff that appears on Facebook, and they're going to make less money.
Yeah,
And
that's a slippery slope, little bit, right, Doug? So censorship has its own issues, right? Because
but see, I'm not saying to censor. I'm saying you can post. You can post that Douglas Duncan stole $100,000. But if that's not true, and I sue you in court, you're going to have to get a lawyer, and you may very well be responsible for the slander that you published. So I've not stopped you from publishing. There's no prior censorship.
Right.
But there's the responsibility for putting something out in public that can cause harm when it's not true.
Right. And so what's the law now? I know that Facebook and social media channels like that are not held accountable. I cannot even see how they could be held accountable because just the sheer volume of it. For somebody.
Oh, but wait a minute. We got to jump in there, okay? They were given a special law, and I'm not a lawyer, and I would have to look up exactly what the law is. But there was a law that was passed, I think, a couple of decades ago, that gave special immunity to the social media, immunity that you don't have, that a newspaper doesn't have. They got a special pass.
Right.
Okay? And what I'm saying is I think it's time to remove that special pass and to make them responsible. And, in a newspaper, there's probably one editor for every 30 writers. And there's fact checkers and proofreaders. Right. So the reason that Facebook can make more money than the New York Times is the New York Times has a much bigger infrastructure of people, but that allows it to do checking. And so what I'm recommending is it's probably time to take that special exemption away from the social media companies and make them responsible for what they put out there. And that might and probably would mean that an actual human being will have to read each post. And I'm well aware of that. And I think that's fine. I think that, as you said, the danger to our whole system is so high that whether Mark Zuckerberg and company make $10 billion or it has to go down to $3 billion that they make, or even $1 billion that they make per year, I think that's a good trade-off.
Yeah, I see bit of a difference there, Doug. Let me throw this out to you to get your perspective. So, New York Times is producing content. So when they print something, they're responsible for that content. Facebook is really a transport mechanism. They're not really producing content. They actually have, it's basically a medium that allows people to communicate with one another, right? So I agree with you that laws, so that the content maker in this case is actually the person who's posting it and posting information, misinformation, whatever it may be. That person should be held accountable. I don't know.
I think your solution would be a workable solution as well.
Yeah.
Anybody who posts something on Facebook posts it under a name that is attached to them. And if something appears on Facebook which is false and harms me, then rather than suing Facebook, I sue the person who posted it. I'm totally fine with your solution. What I'm not fine with is that someone under a name which is hidden and not connected to any responsible person publishes on a medium, Facebook, which is also not responsible, and then all of a sudden you're flooded with information which can be harmful, for which no one is responsible. Right. I think that's the situation we're in, and we're finding out that the downsides of it are very, very serious.
Yeah, so the most elegant solution, I don't think we will be able to get there, is that anybody who actually gets information from social media uses some sort of a scientific process to reach a conclusion.
Well, in the meantime, of course, everyone listening to this podcast can do that.
Yeah.
And that's how you protect yourself. As a matter of fact, my favorite very short definition of science is something that I heard Richard Feynman once say way back when I was a student at Caltech. Somebody asked him, "What is science? Can you really define it for me?" And Feynman thought, and he said, "I think science is a way of trying not to fool yourself." And I personally add to that, or be fooled by other people. Right. So if you do checking, if you ask what is the evidence or the data behind this claim, you are indeed trying to help yourself not be fooled.
Right.
However, as a practical matter, I think that dumping reams and reams of misinformation, often dangerous misinformation, on top of people is not very wise for society. And I realize people make slippery slope arguments all the time, but I do think that's what wise laws address. And, even the Supreme Court has addressed that. They say freedom of speech is guaranteed by the Constitution, but not the freedom to yell fire in a crowded theater. Okay, well, freedom of speech is not absolute, because there are times in which it's so counterproductive that it can actually kill people, like yelling fire inside at a concert in a theater. Right, so you can't do that. Can you yell, "Don't wear a mask, don't wear a mask"? How many people does that kill? Okay, I agree with you, it's a slope, and it's slippery, but I do think that even in a world that has slopes on it, the wise person figures out where on that slope you need to draw a line.
Yeah, I mean, the irony, Doug, for me is we can actually easily train a machine today that wouldn't make many of the logical errors that a large segment of the population makes by getting raw data from social media. We can actually train a machine not to do that today with existing technologies.
Mm-hmm.
So what does it say about humans? Is it that, in some sense, one could argue we are progressing backward, right? We are sort of delegating activities to machines, and at some point we will delegate thinking to machines too. and we may not be too far away from it right now, actually, because
Yeah. Yeah.
look at how much time a person takes today to reach a decision. It's a few seconds. There isn't lot of analysis or thinking that goes on before that person reaches a decision based on social media data, right?
Yeah. Yes.
And so it's the question. Then it goes back to education. Then, so I fully agree with you that the process of learning has to be really stressed. It's not the content; it's really the process of learning. And I know that certain countries like Finland and some Scandinavian countries have moved away from what I would call systematic curriculum-based education. You go and you learn physics, chemistry, biology, and then you could go physics 2, chemistry 2, biology 2 type thing. But rather they say you sort of design what you want to learn, and they are actually providing higher level of importance to the process. So is a solution,
Yes.
a redesign?
I think another way to perhaps to put what you just said, um, does the system come about so that it's designed and all the humans have to fit the system? Or is a system designed on the basis of the humans in order to better serve the individual person? Somebody might correct us if we're wrong, but I believe our educational system was designed a century ago to mold very similar people to work in factories. And, one good thing about the information revolution is that there's more variety in the world now. There are fewer factories. But why in the world are we forcing all the people in our educational system to fit in these little predefined boxes? So I think that the countries like Finland and the Scandinavian countries are really onto something quite important. Now, again, I'll go back to something I said before about efficiency. It's more efficient. Most efficient thing you can do is to get a whole bunch of students to memorize an answer. But that doesn't serve them well in life. And I think a challenging thing for people trained in economics is there's probably an almost unstated acceptance that efficiency is good. But I think that's worth thinking about, and I would encourage you to talk maybe more with a psychologist. There was a wonderful person at the University of Chicago when we were both there, who made Mihai Csikszentmihalyi, who made his life's research what makes people happy. And now there is actually a little field of science called happiness studies.
Yeah.
And I think you'd find it fascinating to have one of those people on. But I do know some of the results. And the Scandinavian countries that we just mentioned tend to have a population that's happier than the average American. And so I think that we can logically conclude from that just having a handful of big businesses that are very efficient and make a lot of money, the Facebooks and the Comcasts of America, that doesn't automatically make people happy. I'm glad to get an internet that I can talk to you courtesy of Comcast, but I have to honestly tell you that happiness in my life is not driven by Comcast. Okay? And so when you talk about education having an important role, that's so true. But I think one of the challenges of the 21st century, one of the opportunities, it's a challenge, and we haven't really picked up on it, is to mold our educational system and even our society to pay more attention to the humans. You know, we're not as efficient as the IBM computer that can explore a million possibilities in less than a second, but we are human. You know, and there are certain things that make humans happy, and I think we ought to be cognizant of that. In the old days, it made sense to train everybody to work in a factory because that was most of the jobs. And the things that came out of factories were all pretty much the same.
Right,
but
right.
We do live in a world where, thanks to intelligence and computers and artificial intelligence, everybody can publish their own book, and they can have their own podcast, and they can do things in a very individualistic way. That possibility and potential is there. But I don't think we have prepared people too well to seize the advantages of that and to push off the disadvantages of that. So somehow we need to equip people. It's almost like the society in which we live in is changing faster than the people in it. You know, and so it means there's potential, but it's only potential if somehow you've been equipped to use it. So that goes beyond science, right? It goes all the way to philosophy and social science and to future guests.
Yeah. I wondered, again, sort of abstractly, Doug, that the first problem is sort of the scale problem. So we go back to Scandinavian countries, 8 million, very, very sort of uniform, for lack of a better term, population. And the experiments that we see there and the conclusions we take from there may not be applicable at scale in very diverse systems. So that's one issue.
I think the data contradicts that, because there's a part of what you just said. I'll take all that you said and I'll agree with it, and I'll put then comma for the amount of money we are willing to spend. Okay? We start our average K through 12 teacher. Some of my students go on to teach high school science. And they start at $40-something thousand a year. If they go just down the road in Denver and they design some plastic for your swimming pool cover, they get paid $75,000 a year. If you are a science teacher in Finland, the last time I checked, you got paid $90,000 a year. And you know what the result of that is? You pay a little higher taxes, but you get a way better teacher on average for your kid. Because the people at the top of the class are going to work educating kids, whereas in America, all the people at the top of my science classes are going to work for businesses that pay them more. So I think it's not a matter of you couldn't do it. I think it's totally a matter of priorities. If you thought it was worth it and important, not only to the success of your child, but to their happiness, to have them be taught by some of the most accomplished and charismatic and motivated students, then you would be willing to pay probably a good 50% more for each of the teachers that teach our kids. And if I say to people, even alumni of my university, if we paid a little bit more, we'd get a better coach for the football team. Boy, they are all over that instantaneously. So I think the rewards of having some of the top of our college students go and teach the kids of all the people who are listening who have kids would be an enormous impact. It's probably the first thing I would do, because rather than change the curriculum or something, a really knowledgeable, motivated teacher will do this on their own. They will figure out what the kids really need to succeed and be happy, and they will work to make that work. We just have not chosen that yet.
Yeah, yeah. So in conclusion, Doug, so in the education system, you talked about compensation, sort of a design aspect. In the policy arena, we talked about maybe changing the status of the social media or perhaps some other legal framework that might reduce the misinformation. If you look at all of this, if you look forward 5 years, think about all the constraints we are in, both from an economic perspective as well as whatever the pandemic is going to bring. What do you think? What do you think? I'm more interested from a policy perspective that policymakers should focus on to reduce this issue.
Yeah. I'm going to come back to the social media
Yeah.
and I'm going to cast it in the following way. I think that the leaders of the social media have very deliberately kind of hoodwinked most Americans, educated or not, to believe that it's absolutely so important that Facebook work the way it does now or Twitter work the way it does now that you just couldn't possibly touch us. And my response to that is nonsense. Okay? The social scientists tell us that many people behave much worse on the anonymity of online than they do in person.
Yeah.
And if I'm standing, in downtown Boulder and somebody comes up and threatens me, I'm going to talk to the policeman who's sitting there on the mall, and I'm going to point to that person and say, I was just threatened by this person here. And the policeman's going to haul him over and sit him down and say, what did you say? And there are consequences. Why should somebody be able to threaten you or me or someone else on the internet in a way that they couldn't do in person?
Right. And so you would want some sort of a change in the legal framework.
I think I would call it accountability for what is published. And I actually prefer your solution that people who publish are identified and are responsible for what they publish.
Right.
And maybe all that, that a network like, that a provider like Facebook should be responsible for is to make sure that the people who publish are identified properly, But in the same way, I cannot go to your local newspaper and hand them a story and say, this person is a child molester. I just made that up. Right. And then I hand them the story and they say, who are you? And I say, anonymous. They're not going to publish that. Yeah. Okay, so I think the same kind of accountability, if you're asking me for short term, two things. It's bring accountability back to people who publish.
Yeah.
And don't be fooled by the companies that say, publishing online is different than publishing used to be. No, it's still publishing. And then personally, anybody listening to this podcast can start tomorrow asking themselves the question of Nobel Prize winner Daniel Kahneman. And the question is fast or slow for my thinking. When I read a tweet, when I read a post, I will instantly have an intuitive, emotional response to that. But there's another part of your brain that can say, okay, that was my emotional response. Now let's give some time for my thinking response before I pass this on. And those are the two big things to do right now. And the long-term thing to do is to adapt our education, our teaching, to be the teaching that's needed for the 21st century. And I invite anybody who's listening to the podcast to Google Dr. Doug Duncan, the University of Colorado, and my homepage will come right up, and you can read about my classes, real versus fake science, and real versus fake information, and you can send some feedback. And I would love to hear suggestions from anybody who has listened today.
Excellent. This has been great, Doug. Thanks so much for spending time with me. And good luck with what you do.
Thank you very much. These are really important things. I appreciate your industriousness and
This is a Scientific Sense podcast providing unscripted conversations with leading academics and researchers on a variety of topics. If you'd like to sponsor this podcast, please reach out to info@scientificsense.com.